the domain of a function. Do not forget to subscribe, and if you have any question, feel free to ask or suggest anything. When we introduced the concept of functions, we used only small sets of points. This was done because at that time I wanted you got the idea of what the domain and range of a function are. Now let's return to the subject of domains. To fully describe a function, we need both a rule and a domain. Recall that the domain of a function is the set of all x values that are to be used for the function. If the function is given by an algebraic expression and the domain is not specified, then by convention, the domain of the function will be the largest possible set of x values for which the function of x is defined. It could be the set of real numbers or a subset of real numbers. From this point on, if you have any question about set building notation or numerical intervals, you should watch this video before proceeding. Otherwise, go ahead. Now, let's see how it works. Examples. Find the domain of each function. Look at the example A. All values of x are possible. This function works for any real numbers. But we know that mathematicians don't like writing lots of words when a few symbols will do. So there are ways of saying the domain is. This is the neatest way, I know. But we could write domain is x belongs to set of real numbers. Or domain is all values of x such that x belongs to set of real numbers. Look at the example B. This function does not work if x is 0 because division by 0 does not exist. So the domain is set of non-zero reals, or the domain is set of real numbers excluding 0. Our domain is all values of x such that x belongs to set of non-zero real numbers. We could represent the domain on a real number line and use interval notation. Pay attention. Look at the example C. We cannot take the square root of a negative number, so we must have x is greater than or equal to 0. The domain is the set of all x values that belong to the real numbers, such that x is greater than or equal to 0. We could represent the domain on a real number line and use interval notation. Look at the example D. We cannot take the square root of a negative number and we cannot divide by 0. So we must have x is greater than 0. The domain is the set of all x values that belong to the real numbers, such that x is greater than 0. We could represent the domain on a real number line and use interval notation. Look at the example E. We cannot take the square root of a negative number, so we must have 2x minus 6 greater than or equal to 0. We can solve this inequality to find the domain of this function. The domain is the set of all x values that belong to the real numbers such that x is greater than or equal to 3. The problem we have with this function is that we cannot have a negative inside the square root and we cannot divide by 0. So we will set the insides greater than 0 and solve. Pay attention, when you multiply or divide an inequality by a negative value, you must change the direction of the inequality. The result will be the domain. Look at the example G. We cannot divide by 0, so let's solve the inequality.